section 3B, talking about putting numbers in perspective. Okay. You often hear things like millions, billions, trillions. How much difference is there between a million and a billion? A lot. How much is a lot? You're right, there is a lot of difference. And, you know, if I ask my kids, I won't put it to you. If I ask my kids, what's the difference? Well, huge, Dad. Yeah.
They usually say, like, if you count from 1 to like 1 million, that would take like 3 days, but 1 to a billion takes like a few years.
Okay, yeah, you know what? That's an interesting point. Let's figure that out. Suppose you did one number every second. Okay? And I know at first it's real fast, 1, 0, 6, 7, 8, 9, 10, 11, 12. But when you get to 167,237, 167,238, those are taking more in a second, aren't they? So we're going to assume that you're counting auctioneer style. One number a second. Okay? Let's figure out how long it would take to count to a million. Just for grins. At one number a second. Okay? And you've all seen this before, right? The conversions, 60 seconds, 1 minute. 60 minutes, 1 hour. 24 hours, 1 day. And this is the one that you're getting good at, 365.25 days, 1 year. Now, this is going to give us a number per year. This is going to tell you how far you can count in 1 year, right? So let's see what happens here. So we're going to do 60 times 60 times 24 times 365.25 equals, well, let's see here. This is going to be 315576600. We'll throw in something like that. This is 1 year. To get to a million, well, we've gotten to 31 million, haven't we? Okay. So you can get to a million in less than a year. Okay, so suppose we back this up some. Let's divide it by 12. Well, tell you what, let's do. Yeah, let's just divide by 12. Get a little sloppy here. If I divide by 12, that's going to give us pretty much a month. Does everybody buy that? Okay, so that's going to give us 2629800. Well, we're a whole lot closer to a million, aren't we? So to count to a million is about a half a month. Does everybody buy that? So about a half a month to count to a million. 2 weeks. That's if you don't even take a and you just keep going and you never sleep. It'll take about 2 weeks to count to a million. So there you go. Got something close now. A billion. So let's say 2 weeks is about 14 days. How much bigger is a billion than a million? Well, it's 3 more zeros, so it's no bigger, right? Zeros aren't worth anything. That means it's 1,000 times, isn't it? So we would have to multiply this by 1,000, which should give you 14,000 days to count to a billion. So it's going to be 2 weeks to get to a million. To get to a billion is going to be about 14,000 days. And let's see, I'll do this quick. Divided by 365.25. It's going to take about 38 and a half years to count to a billion. You can get to a million in 2 weeks. You can get to a billion in 38 and a half years. Did you see that big of a jump coming? A billion's a whole lot bigger than a million, isn't it? And think about going from a billion then to a trillion. That's a whole lot bigger once again. Okay? What I'm hoping to do in this section is to allow you to see some situations, work through some things that are more realistic that you would encounter, that you do encounter, talk about some numbers that you are going to hear thrown around. When we move into this, some of these numbers are going to be kind of big. You use scientific notation for that. Has anybody ever seen that notation? Okay, you'll see things like 3.6 times 10 to the fifth. The point of scientific notation is to keep you from writing numbers with lots of zeros. Times 10 to the fifth really means you move the decimal how many places? 5 places. Okay? So this is really going to be the 3, the 6th. I'm going to go 1, 2, 3, 4, 5. Put the decimal down. And I always think of these as being like egg cartons, and I'm just going to fill in the egg carton. So 3.6 times 10 to the fifth is 360,000. What it does is it allows you to write really big numbers in a much easier form. My daughter's taking chemistry right now. They're getting in some of the basics like a mole. And she said that the teacher showed this big picture in the PowerPoint of this ugly mole, a little fuzzy creature. She said, shocked her, she said, I didn't know he had it in him, Dad. Okay, but a mole is 6.02 times 10 to the 23rd molecules. 10 to the 23rd, is that a big number or a little number? That's a humongous number. What we would do is move the decimal over 2 places, and then how many zeros would we still need? 21 zeros after that. How'd you like to have to be writing that down, especially if you're in chemistry? And every time you do another problem, you got to write 602 and then 21 zeros. Okay? So this saves a whole lot of time. It also allows it to be more accurate because at some point you're going to miscount and put 22 zeros or 20 zeros, which throws you off by a factor of 10. It's 10 times too big or 10 times too small. Is 10 times too big a problem? Yeah. How would you like to buy a pair of shoes that's 10 times too big? That means my shoe would start here, and we'll go 1, 2, 3, 4. It would come out to here. Really? Chuck's going to walk in with shoes like that? Okay, that's what 10 times too big does. Imagine your pants 10 times too long. Okay? It gets a little crazy. I don't even want to talk about 10 times too small on shoes. Okay? It's going to be really small. They're about like that. Get them on a toe. So, just missing a zero, it's just a zero, is huge problems. The other way scientific notation goes is sometimes they're really tiny numbers. So you have things like, I'm just making up something, 1.76 times 10 to the negative 8th. Negative means make the number smaller. You're still going to move the decimal 8 places, but now you're going to move it 8 places that will make the number smaller. So we would start out with the 176, and we're going to move it 8 places, but are we going to move it to the left or the right this time? To the left to make it smaller. So 1, 2, 3, 4, 5, 6, 7, 8. Put the decimal down and start dropping in the zeros. Once again, the danger is miscounting and leaving off a zero or adding one too many. The scientific notation protects you from that. Okay? So as we move into big numbers, on your calculators it may start displaying things in scientific notation. On your calculator, this would look like 1.76 e negative 0.8. The e says here comes the exponent on the scientific notation. Does that make sense? So from now on, when we're messing with things, on your calculator, be sure to look all the way over to the right-hand side. You may have never noticed the e there before, may have never had it there before. But there are going to be times where you're going to get displays like that. And you don't want to overlook that because it makes a massive difference to the size of the number. Okay? So we've got that all covered. Gets kind of fun on this stuff. Annual ice cream spending in the United States. Everybody in the U.S., if you add up all the money spent on ice cream in the United States in a year by everybody, would that amount of money be in the thousands, millions, or billions, or trillions of dollars? You gotta be kidding, Chuck. I don't know. How am I supposed to figure that out? Really? How much money is spent on ice cream every year in the United States? That includes everything from McDonald's to Ben & Jerry's. Or Grater's. Really? How am I supposed to do that? Is this a problem? Yeah, this is where that problem solving stuff comes in. Okay? First, understand the problem. You understand what the problem is, right? Are we going to get an exact amount, or are we just going to have to kind of guesstimate? Got to kind of guess. Is it okay to guess? Yeah, that's all we can do. Unless you want to survey every single person in the country. Good luck on that. Of course, even if you ask them, any idea how much you spend a year on ice cream? Why would I know? I just answered. Okay, your survey is going to get a lot of question marks. So even if you talk to everybody, you get a lot of blank. Who are you? Okay? So we start out by making a reasonable guess. Something like each person, 50 servings a year. That sounds a little weird, Chuck. Where'd you get that? Maybe an ice cream a week. Well, Chuck, I don't eat ice cream in January. I know, but what about July? Oh, well, let's not talk about July. Average out to maybe 50 of them a year. Does that sound reasonable? Now, that's per person. I know some people eat more, but there's some 3-day-olds who don't eat any. So it all kind of balances out, hopefully. You get the idea. You got to make some assumptions and get kind of sloppy here, don't you? This is math, Chuck. You're not supposed to be sloppy. Yeah, well, welcome to the real world. How much does an ice cream cost?
From where?
Very good question. From where? McDonald's, it's 99 cents, isn't it? Okay. Grater's or other places, it's more. United Dairy Farmer, about $3 a serving. Sound reasonable? Can you live with that? Some of them more, some of them less. Okay, so if you're paying $3 a serving, getting 50 servings a year, how much is the average person go spend on ice cream? Okay, this is where we got to be careful about the number of zeros. What's the 3 times the 5? 15. And then how many zeros come along after that? 1. So the average person, we're guessing, spends about $150 a year on ice cream. Okay, so what's the next question? How many people are there in the United States? If you're not sure, you could quick check online. I think it's about 365 million, something like that. I'm not quite sure. I didn't check this morning. But I'm going to guess. Let's say 360 million people. Okay, so how are you going to figure out the total spent on ice cream? Multiply. It's going to be the 150 times 360, 0, 0, 0, 0, 0, 0 equals. And I don't know about your calculator, but what mine spit back was 5.4 E10. Huh. How much money is that? Well, let's put the zeros back in and see if we can figure out what this looks like. So we're going to have the 5, the 4, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll drop the decimal there, and we'll carefully put in zeros in each of these spots. Now, one of the cool things about doing this on the Excel spreadsheet is when you erase a line, the whole line disappears. So that we've got this free now to put in the commas. How big of a number is that? Is that thousands, millions, billions? What is that? covered. Some folks said some of each. Let's count it up. This is the hundreds. This is the thousands. This is the millions. This is the holy mackerel. About how much money is spent each year on ice cream in the United States? $54 billion. Did you see that one coming? Big industry, isn't it? Okay. Does that make sense? Now, is this number exact? No. We could go online and search total spent on ice cream in USA. And it'll give us some kind of a number. It'd be interesting to see how close they are. But even if we're off $1 billion or $2 billion, it's still a lot of money, isn't it? You know, it's not millions, it's measured in billions of dollars. Does that make sense? Okay, we'll call it quits here for today.